Hello, everybody, and welcome back to another episode of Astrophysics Research Basics. Yay! So today we're going to be going over a matplotlib tutorial. So in this tutorial, I'm going to be using imshow. So I'll be teaching y'all how to use imshow to showcase your data. But there are many other uses of matplotlib, so I'll probably be making other tutorials in the future, but for today, it's just focusing on imshow. So I'm going to share my screen, and I'm going to be teaching y'all how to make this plot here. So I made a pretty complex plot, so I'll be going over the steps on how to make this kind of plot and breaking it down for y'all. There are lots of pieces in this plot. So here's a quick overview of what we're going to be doing today. So this long piece of code here. But in this Jupyter notebook, I've kind of pieced it out so that we can go over each of the pieces together. So in general, as you'll see in this plot, there are two subplots. So in matplotlib, generally the whole thing is called the figure. And then within the figure, if there are multiple plots, they're called subplots. So this is one subplot on the left here, excuse me. And then here on the right is the second subplot. And there are other pieces, like here's a title up at the top. There's this color bar at the bottom, and there's lots of labels here. So we'll go over each of these pieces. So I'll start at the top here. So first I imported some stuff. So we're going to grab our data using a fits file. So I imported fits, and I also imported matplotlib pyplot. That's usually what you're going to be importing it as, PLT. It's the common usage. I'll import it as PLT. I also imported OS because the files are on my computer, so I grabbed them using OS, and then NumPy to, I guess, manipulate the numbers a little bit, copy, which I'll talk about later, and then WCS because our plot uses WCS to showcase these coordinate things. So this coordinate grid and the location, as in the RA and DEC, that is all WCS information. So we need to use the WCS from AstroPy. Yep. Okay, so in this first cell here, I basically grab all the information I need for the first subplot. So it's from a file on my computer, so I change directory into that folder that I need, and then grab that specific fits file and open it into an HDU. And then I grab the data from that HDU, and then I also grab the header, and then from the header, I get the WCS. So this is how you grab WCS information from the fits file. It's always going to be in the header if it was done correctly. So you just do WCS of the header of that fits file. It's as simple as that. Yep. So all the information I needed, I grabbed and put into various variables. To create this plot, we are going to need to create a figure. So I define a figure by doing plt.figure. So that creates the figure. And then you can also optionally create a fig size. So this is the size of the figure. This figure is longer than it is wide, or longer than it is tall. That's what that means. So it's 8 width and then 4 height. Each part of the figure, there's going to be a left and a right subplot. So you're going to have to define some subplots within that figure. So if we look at our figure, there's 2 plots, right? So we're going to need to define both sides of this figure. So the left side is the first subplot and the right side is the second subplot. So in figures, when you define subplots, they kind of go from the left to the right and from top to bottom. So if you had 4, for example, the first one's going to be on the upper left, then the second one's going to be on the upper right, the third one is the bottom left, and the fourth one is the bottom right. So they kind of go in that order. but we only have 2 in this example. So back to where we were. So we create the first subplot by using plt.subplot and then some numbers here. So then what the numbers mean is you're going to have the number of rows first, then the number of columns second, and then the number of the plot third. So this is saying we have 1 row within our figure, 2 columns within our figure, and this particular subplot is number 1. So if we go down to our figure and look at it again, we have 1 row of subplots. We have 2 columns of subplots. And the subplot we want to define first is this one on the left. Right, this is number 1, position 1. Position 2 is the second one. If there were 4, we could have it 4 in a row, so 1 row with 4 columns, and then it would be 1, 2, 3, 4 in a row from left to right. Or we could have 2 rows and 2 columns by doing 2, 2, and then it would be 1 upper left, like I said before, 2 upper right, 3 bottom left, 4 bottom right, and so on. So you can have as many rows and columns as you want, or as is reasonable, I guess. Where were we here? Okay. But in this particular example, we only have 1 row, we have 2 columns, and then we particularly defined this as the first subplot. So that's what these numbers mean. It's a little confusing at first, but if you play around with it, I'm sure you'll get it. Yep. So in particular, I called this AX because this function gives you what's called an axis. So we're going to define this as AX, just standing for axis, this particular axis. Okay, but really, we want to project the CS or WCS eventually on it. So this is what this commented out line is. So we're going to go back to that later, but we're going to change this subplot to project the WCS once we get to that explanation later. So we're going to have to add this little portion here, but for now we're going to go on. We want to add the data to that subplot that we just defined, because if we just ran this, it would just be an empty subplot with no data in it. So what we're going to use is imshow. So ignore these first 2 things for now, but right now we're going to define an imshow instance. I just did a random thing, C. And then our axis that we defined earlier, we're going to do axis dot imshow. So this imshow is from this, is one of the things you can do to add to this axis. So we're going to do imshow. And then we're going to add the data. So this is where our data is. I just wanted it to be in log scale, so I did numpy.log10 to put it in log scale. And then this is the data that we got before. So if you see from here, this is the data we defined from our HDU before. So this is data, and then we're going to do comma, and then a bunch of stuff that I'm going to talk about. So when we use imshow, we're going to eventually want a color bar and to color it using a certain color map. So in order to do that, we need to set a minimum and maximum value for our color map in our color bar. So I just set them up here, and I set them separately than just putting the value in here like this. I set them separately like this because I also want the second plot to have the same one. So I just set it as a variable, and as you'll see later, you'll also use the same variable vmin and vmax to define the color limits. So you set some limits, and then you set what the color map color is going to be. So there are lots of different options for this. You can just look it up, like matplotlib cmap options or something like that. You can look it up, and there are tons and tons of different color maps you can choose. Rainbow is I guess, common one in my field, I guess, astrophysics. So I just set it to rainbow, plus I think it looks cool. Then this aspect ratio thing is talking about the difference in size between the subplots. But for now, I don't think we need to worry about that. And then interpolation nearest. So this is something I learned recently. So basically, if you don't set this to nearest, it might mess with the size of your pixels. So when I didn't set this to nearest, I noticed that some of the pixels were weird sizes. And this has to do with how it, I guess, interpolates the data into the actual pixels on the screen. So sometimes it doesn't match up one-to-one, so you need to set it to interpolation nearest for it to most accurately, I guess, represent it correctly. And it was pretty annoying trying to figure this out, so take this information and use it to your benefit. Yes, you put interpolation to nearest. Okay, so now this actually puts all the data onto our subplot. Next, if you want, you can put an X in the center of the object. So right now, the data that we're showcasing here has a center. So this is actually a galaxy that I'm working on right now. And so I wanted to mark where the so-called center was. So I put an X where this center was. And so I put this in just to showcase how you can put various marks on your plots. That's not the data. So you can put this X wherever you want. It doesn't have to be the center of your object. It could be any sort of mark that you want to put on your object. But if you have coordinates and you want to put the X, related to the coordinates and not necessarily where the pixels are, you can use this function called WCS world to pixels, world to pix. So you put this WCS object, which we created up here. So this is the WCS object. And then we use the function WCS underscore world to pix, which is basically converting from RA and dec to pixel value within the image so that you can know where to put that mark in terms of pixels. So I put in the RA and dec of the center of the object that I wanted to mark. So this is RA and dec. You have to do double brackets here for some reason. And then you have to put a 0 here for some reason. I'm not sure why. But that's just how this function works. And then you use the same axis that we defined earlier, because this is the subplot 1. And then you just put plot. Plot is just the general plotting function. So we're not going to use the imshow because this is not some image. This is just a single mark. So we're going to do plot. And then the location of this pixel value, the X pixel value, and then the Y pixel value. And then this is just the particular mark. So the first value is the color. K stands for black for some reason because B stands for blue. So if we made this B, it would be blue. The X would be blue, but I wanted it to be black, so I put K. There are lots of different things that you can look up for plot, including like the various different colors, as well as instead of an X, you can do like a small dot, or you could do a larger dot, etc. There's so many. You could do dashes, lines, lots of different things. You can look it up. But I wanted an X, so I did a black X. That's what this stands for. It needs to be a string here, which is why I have the quotations. So now we're going to worry about the WCS overlay. So if you aren't using WCS, you don't need to do this stuff here, but we're going to go over it anyway for the information. So if you want to put an overlay on your imshow data, then you use this thing called get chords overlay, get underscore chords underscore overlay, and then you choose the certain coordinate system that you want for your WCS overlay. So I just use this ICRS, which is standard. There's also like galactic or other systems you can choose. And then we're going to want to change this up here. So if you remember from before, I mentioned there's this projection thing. So we're going to add this projection thing to our axis and then insert the WCS object here. So remember the WCS object was this that we defined up here. So we're going to add it to the projection here. And then we're going to put a grid here to, I guess, make it easier to see those WCS location things on our plot. So you can set the color. I set it to black. And then this is the line style. LS stands for line style. And I want it to be dotted. So I put dotted. So yeah, so this adds the grid from the overlay that we defined. And then I didn't really like the particular labels that they chose to put next to the plot. So if you look here, I added So there's this deck label here, RA label here, deck label here, and RA label here. I actually changed those to say that because I didn't like how it was before. If you just put it without changing them, it'll have it on all four sides of the image. And if you have two subplots, it all kind of gets jumbled up. So I just wanted it on the edges of the image. So I changed it with these things here. So we can read here. I changed the default labels to only be on the left and the bottom. So as this is the first subplot, I only wanted it to be on the left of the subplot and the bottom of the subplot. And so you'll see here, there are two sets of labels I figured out that are going on here. And that's why they're covering all four sides of the square, rectangle, or whatever plot shape you have. The left and the bottom are defined with the ax.chords here. And then we'll see later, but this defines the top and the right, and I just set them to blank. So for some reason, there are two things here, so make sure you're careful about that. So that was the first subplot. A lot we went over, but that showcased all of it. So we're going to just kind of go fast over the second one because it's pretty much the same thing. So this here you can basically ignore, but it's basically me grabbing the data for the right subplot as well as the WCS. So I grabbed the WCS here, and I had already previously defined in some other code this NA_H beta data, and I wanted to make a copy of it for this tutorial, so I used copy.deepcopy. You have to be careful about this because if you just set a different variable equal to this data, for example, like this, you are not copying the data into a different variable, you are making another reference to that data. So if you change this variable here, this new variable, it will also change this variable that you referenced it to. So you have to be careful. I did not want to do that. So I made a copy of it using copy.deepcopy. And now if I change this new variable, it does not change the variable that it copied. Have to be careful about that. So ignore all this stuff that I did to it. That was just because I wanted to make it in the same units as the previous data that we got for the first subplot. It's worth noting this line here. I changed a bunch of these values that were like super low in this data to be equal to numpy.nan. And what setting a value to numpy.nan does in imshow is it makes it look white. So you notice all these white values here. It's because those values are nan values. And this is useful if you have some data in a range like this, but some of them are bad values, like bad pixel values, or you just like don't want to show that data. You can just set it to numpy.nan and it will just make it look white like this. Pretty useful. Okay, so next we're going to make the second subplot and add the imshow data to it. So basically here, you'll notice that the 1 and the 2 are the same as before. So this is 1 row, 2 columns, if you remember. Do you remember? And then here's the position value. So we want position 2, right? The first one was position 1. We're going to want position 2 now. Same projection, but the WCS value is different because we're using the WCS from our second set of data. So a different WCS projection. And then this here is just because the data that we're using is 3 dimensions, not 2 dimensions. So I had to just take a slice of that data. So the same X and Y, and then just a slice of the Z axis. But you probably don't have to worry about this if your data is in two dimensions. I just added this because my data was in 3 dimensions. Okay, and then we're going to add the data through imshow, same as before. Here's the data variable CMAP rainbow. You're going to want to set it to the same value because we're using one color bar for both of them. If you want to use 2 color bars, which you can, 2 separate color bars, you can use 2 different color maps, but we're using the same one. Then the same Vmin and Vmax values from before that we set up here. You want to keep them the same if you're using 1 color bar. It's very important to do that. Otherwise, the color bar will just be from one of them, and then it'll be off for the other. So you want to make sure you set these Vmin and Vmax values to be the same. Remember, this was just the size between the plots. We're not going to worry about that. And then remember, this interpolation was to make sure the pixels were reasonable sizes. Okay, then this is the same as before, adding an X to the center of the object, but we're using the different WCS variable so that this particular subplot uses its own WCS label. I don't know if y'all are hearing that like big booming sound, but that's because it's raining and thundering outside. Yep. Okay, so this is basically the same as before, so we're not going to go into it. This also is the same as before with adding the overlay, but now we're adding it to axis 2, same as here. So remember to change the axis value to the certain second axis that you defined. And then here, we want it to be on the right and the bottom. So we set this to be the right value, and this to be the bottom value. Then the other two are blank. Okay, and then here, this is somewhat important. If you want to just stylistically change things, one of the important stylistic changes is you can change the spacing between subplots. Oh, I misspelled here. So this is the width spacing, so the spacing with the width between the subplots, and this is the height spacing. So if you had two subplots on top of each other, you could change the height between them. Right now, we only have width relations because we have two subplots next to each other, so only the width matters. So I changed the width spacing to be 0.2. I wanted to add a little bit. This is adding a little bit of spacing between them because the labels were overlapping each other earlier. So I changed it to be this. So yes, the subplots underscore adjust changes that. Okay, next. This stuff looks complicated, but I'll explain it. So basically, if we look at our plots here, there are two different sets of WCS coordinates, right? Each set of data has its own set of WCS coordinates. And this first plot actually is much wider in its like, I guess, location than the second one. Basically, it covers a larger, I guess, region of space. And I wanted them to both show the same region of space in terms of WCS. So if you look here, they actually match. So if you look here at the ticks, 15 arc seconds, etc. This one also starts with 15. And so they're the same location of space in terms of RA and DEC. But that wasn't the case at the beginning. And you might also have this. If you're using two sets of data, one might cover a larger range of space than the other. And if you want the plots to show the same location in space, you actually need to like limit what it's showing in imshow. So since this one on the left had a wider range of space, I just chose it to limit what it showed to the location that the plot on the right shows. So that's what I did here. So basically, we're going to use pix to world and world to pix from this WCS conglomerate of functions. So this WCS underscore data is our plot on the right. So basically, I took the pixel value of the upper left and the pixel value of the bottom right of that plot on the right and converted it to WCS coordinates. So this pix to world function, WCS underscore pix to world, takes a pixel value and converts it into an RA in DEC, basically. So I did that, and then I converted that RA in DEC to the pixel value of the plot on the left. So I'll repeat that. First, I took the pixel value of the plot on the right and converted it to WCS, aka RA and DEC values. I did this for both the upper left and the bottom right pixel values. Then I converted those WCS coordinates into pixel values of the new plot, which is the left plot. So now we have pixel values for those same WCS coordinates, the RA and DEC, for the upper left and the bottom right locations. And then I used those pixel values to set a new limit for the plot on the left. So now the plot on the left and the plot on the right show the same location. Yeah, so this bottom 3 lines of code is basically setting the limits of the plot on the left. So we'll set X limit and then set Y limit. So that's just what these things are doing here. You'll notice there's this 1000 number here. Remember, this was just because my data here was in 3 dimensions. So if you have 2 dimensions, you don't need to include this 1000 value here. We're going to worry about the color bar. So we can define a color bar by doing figure.colorbar, and then C is just one of our imshows. It doesn't matter which one because we set the same limits for both of them. So it doesn't matter which one we use. Then we're going to include both axes because in this particular plot, the color bar is affecting both of them. If you had multiple, you could define however many you wanted. So you could do a 3rd axis, a 4th axis, etc., however many you're using. But since this color bar is affecting all of them, we're going to use both of them. You could also set a color bar for each of them, but right now we're just using one. Then I shrank it a little bit because I didn't want it to be so big. And then I put the location of it to be on the bottom because I thought that would be best for how it looked. And then you can also set a label for it. And this is pretty cool. What you can actually do is use LATEX to make it look pretty. So for example, here I have a 10 small case, so below it. I also have a 2 here above this centimeters. I also have this angstrom sign here. So it's not, you're not able to do that actually by just typing out, like if we just did C bar, set label, and we just wanted to type a string, we could not just put like erg angstrom and it would do that. Or centimeters up to. We can't just do that and it'll just put what we did before. We can do that using LATEX. So to use LATEX, what you do is you just put an R before your string, and for some reason it'll just automatically know it's LATEX. So you do an R before the string, and then you just put LATEX. So in LATEX, whenever you want to enter what's called math mode to enter special symbols or do the bottom or lower upper case, you do these money symbols, and then to do the bottom case, you do this underscore and then do whatever you want to be on the bottom. And then you can also do certain symbols, like for example, the angstrom symbol is this /AA. And then over here, I added the upper 2. You can also do things like fractions and things like that. LATEX is pretty cool. This is not a LATEX tutorial, so I'm not going to go into it. But basically, if you want to use LATEX, you just put this R at the beginning. And you can do that in any label. So this was the C bar label, or color bar label, but you can do that in any label you have on your plot. Like, for example, this one. So we want to set a figure title. It's good to put titles in your figures. So I just did subtitle, which is the big title across all of your subplots. You can also do titles for specific subplots, but I wanted to do one single title across all of them, so it's called subtitle. Then you'll put the title itself, which I just did as flux, and the font size you can change here. But you could put LATEX here by just putting an R and then doing whatever fancy LATEX stuff you want to do there. But for this one, it was just flux, so I didn't need LATEX. Yep. And so, yeah, we went through all of this together. It looks like a lot here, but broken down, it's not actually that bad, I hope. And it creates, hopefully, this plot here. So we have a rainbow color bar with the same -2 and 3 limits that we set for both of them, so it should be accurate for both. We have this fancy LATEX label for this color bar. We have a subtitle flux that covers both of them. We have labels for our WCS that are just on the edges of the plot, the left and the right and the bottom. You got rid of the top and the insides. We have the dotted lines for our grid showcasing our WCS overlay. The overlay does the ticks as well. We have the imshow data plotted, separate ones for each one. And then we have the X showcasing a certain position in the WCS within our plots. Pretty cool. We did a lot of stuff today in this plot, but we managed to create this plot together. So yes, very exciting. I hope that was helpful and was a general, I guess, overview of how to use imshow from Matplotlib to showcase your data. Hope to see you back again in another episode of Astrophysics Research Basics. Bye-bye!